So we really just have looked at Aufbau's principle. Let's look at Pauli's exclusion principle with the electron spins in two different directions. Let's use Hund's rule. Let's take a look at carbon. Periodic table tells us that carbon has 6 electrons. You'll notice here I'm doing a different type of orbital diagram, so this would be something that you would write out on your own. I just happen to have it already pre-made here. So I've got the 1s, the 2s, the 2p, and if I happen to go higher than that, then I start following that order, the 3s, the 3p, and so on. So here we go with 6 electrons. 1, 2, that one's full. 3, 4, the 2s is full. I have 2 more electrons to place. According to Hund's rule, I have to put 1 in each of the remaining orbitals before I can double up. So I'm going to put my other 2 electrons as indicated here. The electron configuration for carbon would be 1s2, 2s2, 2p2. Again, you add up the 2 plus the 2 plus the 2, that gives us how many electrons we have in that element. Let's do chlorine. Now, if you look at the periodic table, chlorine is element number 17, and so we have to extend our orbital diagrams out further. So we're looking at 17 electrons here. So let's start filling them in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. Notice as I was filling out the orbital diagram, I followed all 3 of the electron configuration rules that we've talked about. And now notice how this is getting really unruly, and we're only on element number 17. So you can see how these orbital diagrams would get kind of long and maybe a little obnoxious. And so for the bigger elements, most of the time we're just going to worry about the electron configuration. Again, we're just writing what we have. We have 2 electrons in the 1s. We have 2 electrons in the 2s. 2p6. 3s, 2, and then 3p, 5. Keep in mind, if you look in the back of your textbook, I'm not sure if you've looked there yet, but on the back of your textbook, on that periodic table, there are electron configurations already listed for you. So for a lot of this work, it's easy to check your work. You've got a key in front of you. So while I tell you that, I don't mean for you just to copy down the work from there, because remember, on the day of the test, you won't have that form of the periodic table. So please use the back of your book as a guide. But be careful. The back of your book, that periodic table there, has the wrong energy order for elements after element number 21. So be really careful of that. Let's take a look at this pattern. Now, you've already marked up your periodic table, or maybe you haven't, but maybe you should. We've already looked at patterns on the periodic table. This periodic table that you're looking at right now tells you what fill order things are happening in. So if we're looking at hydrogen and helium, then the orbitals and the energy levels that are being filled is just the 1s. So if you remember what we came up with, this is 1s1, 1s2. In the next row, the next period, the orbitals that are being filled are the 2s2, the 2s and the 2p6. Well, that pattern looks like this, and this would be 2s1, 2s2, 2p1, 2p2, 2p3, and so on. Now, we're setting up a little pattern here. We're not going to fill out the whole periodic table, but if I asked you, well, what would the ending of strontium's electron configuration be? Well, you should be able to tell, well, it's in the 1, 2, 3, 4, it's in the 5th energy level, it's in the S block, so the ending of strontium's electron configuration should be 5s2. Or let's look at arsenic. Arsenic is in the 4th energy level. It's in the P block, It's the third element over, and so its ending for its electron configuration will be 4p3. It's a quick way to make sure that you are reading the periodic table correctly. Now you can use the periodic table simply to help you figure out the electron configuration without doing anything else. If you know what blocks things are in, and you remember these numbers, that's the third, fourth, fifth, and sixth energy level, and this is the fourth and the fifth energy level, then you could use the periodic table as a guide to figure out the electron configuration for almost anything. I know I've gone through this really quickly. We're going to do a lot more electron configuration problems in class. In fact, we're also going to learn how to do the shortcut. It's called the noble gas configuration shortcut. I think the book talks about it, and we're going to put it into practice. Luckily, there's no math involved, so we're just figuring out patterns of the periodic table and figuring out where electrons are and how to notate that. So that's what this entire last two sections of your book have been about. So please bring questions to class, and we will do lots of practice problems next time.